Hey everybody, and welcome back for class 2 in our Algebra 2 math class. Let's take a look at what's going to happen today. So objectives, we got increasing and decreasing function intervals. So what does that mean? How do we write the interval for that? We're going to talk about average rate of change and then also positive and negative intervals. So there's 3 focus points on today, none of which are particularly difficult, but they all just need us to talk about it briefly just to say, okay, this is what it is, this is how you do it. Central questions, how do I write an interval? So that was from last lesson, but in this case for an increasing or decreasing part of a function. How do I calculate the average rate of change between two domain values? And then when is a function positive or negative? So if you can answer those 3 questions, you are good for today. Recap. So what we did yesterday or in our last class video. Rules for functions. So when is an equation classed as a function? Domain, range, and end behavior. So what are they? How do you write them using intervals? And what's the proper notation? So the interval notations we talked about were inequality set and interval. Today, increasing and decreasing functions. So this is going to be pretty straightforward. An increasing function is when the slope or the direction of the line is going up. And then decreasing is when it is going down. So I'll show you very quickly. The increasing parts of the function here, this is a cubic function, it's got 2 turning points. Increasing is the part that as we are going from left to right, the y values are increasing. So increasing is going up. It then becomes, it becomes flat for a second. So at the turning point, it's flat. There's a slope of 0. And then it becomes a decreasing function. So it starts to go down to that turning point. So again, we go flat, and then it actually becomes an increasing function again. So it's just from left to right. Is the y values going up or are they going down? If it's going up, it's increasing. If it's going down, it is decreasing. So what you are going to have to do is say, the function is increasing from this domain to this one. And remember, I use the word domain, so that is x values. Most things we are going to talk about will be in relationship to the x values. So between what x values is the function increasing? Between what x values is the function decreasing? And you're going to write those using inequality set or interval notation. So let's actually do that. So looking at this one, it goes up from negative infinity. So it's going, all the way down here to negative infinity. It's going all the way left to negative infinity to this point here, which is negative 1.55. So we're going to say from negative infinity, and I'm going to use inequality notation today. So negative infinity, you can use any of the notations. It doesn't matter which one you use. I think I used interval notation last time, so I'm going to just practice my inequality notation today. Less than x, because we're always talking about what domain values. And then it's less than negative 1.155. Now, why did I put less than? Because at negative 1.55, it's a turning point, and at that particular point, the slope is 0. It is flat. So if you were to imagine, going back to geometry, the idea of tangents, so a straight line that just touches it in one spot, like that'd be one point of contact here. What you will do in calculus a lot is figure out what is the slope at a certain point. So like if you were just stop there and draw a tangent, what would the slope of that tangent be? At a turning point, it is flat, it is 0, so it is neither increasing or decreasing, it is flat. So that will be one interval where it's increasing. So between the 1.55 to negative infinity, and technically it goes all the way out here, it is increasing. And then also from positive 1.55 to the right, it is also increasing. So we're going to include that one too. So it just gets a separate notation. So 1.155 less than x less than, and it goes to the right forever, so positive infinity. So there's 2 intervals. So we got interval 1 and interval 2 where it is increasing. Decreasing, well, the only place it's decreasing is in the middle here. So the slope goes positive from left to right, hits a turning point, starts going negative, and then turns around and goes positive again. So there is a brief moment where it is negative. And we want to find out, okay, when is that? So the two x values, we can see them marked using the coordinates. We got negative 1.155 less than, still talking about x, less than positive 1.155. The biggest mistake that people make is typically that they talk about the y coordinates instead of the x coordinates. So like, it's not decreasing between 3 and negative 3. Because just think about that. If you said between the y values of 3 and negative 3, it's decreasing. Well, there's also 3, negative 3, like there's also this part of the function, which is not decreasing. So it wouldn't work to talk about the y values. The domain works because it's a function. So there's only one answer for every x value. So we would say, okay, between the domains of negative 1.155 and positive 1.55, the slope, the average slope, is going down. It is decreasing. All right, your turn. I want you to pause the video and try and write the intervals where it is increasing and decreasing. And just a hint, there are 2 increasing intervals and 2 decreasing intervals. Make sure you have both of them in each answer. Off you go, pause the video, come back when you're done. Okay, welcome back. Let's take a look. So we'll start with increasing. So it's going up. So first part goes down, hits a turning point, goes up, hits a turning point, goes down, hits a turning point, goes up again. So between this point and this one, it is going up. Anything to the left of that turning point is going down. Between those two kind of close together turning points, it's got a negative, it's decreasing. And then anything to the right of that is going up. So we need our intervals between the turning points, essentially. So first turning point to second one, x value is negative 1.326 less than x. So remember, these are all going to be less thans because at the turning points, it's no slope, so it's flat, it's not included. And the next turning point is 0.469. That's my first interval, so that's this part, check. Terrible check mark. Second one would be from the 1.607 to the right. So 1.607 less than x. Now it's going to the right forever, so we would say it's going to be less than positive infinity. So anything to the right of that x value is going to have a positive slope. So we did that one, done. Much better check mark. Let's go decreasing. So first one, anything to the left of that turning point is decreasing. So the lowest value, remember, is going first. That's negative infinity. So negative infinity less than x less than negative 1.326. And then we move on to the next one. So that's between the two close together turning points. 0.469 less than x less than 1.607. Now what you notice is that between the two intervals, you pretty much account for every part of the function. The only time you wouldn't account for every part is if, say, like it went, let's say like down, flat, up, flat, down. Like the bits between the flat parts would not be in your intervals. So you would say, okay, it's neither increasing or decreasing there. If it's a curved line function, so like a quadratic, a cubic, this one is to the power of 4, then you would notice that every part of the function is accounted for except for the turning points. Next up is average rate of change. So this is also known as rate of change. What is it? That is our slope. So we talked about the rate of change of linear functions. That was the rate at which the y values changed as the x value increased or decreased. Who remembers slope formula? Take a second, challenge yourself. Do you know slope formula? y2 minus y1 divided by x2 minus x1. So the difference of the y's divided by the difference of the x's, also known as rise over run. We're going to need that. So if you don't remember that, or if that was a struggle for you, write it down, have it in your notes somewhere, because you're going to need it. So the average rate of change, so you think about average, that would be like, okay, there's a bunch of different rates of change, and we want to know, like if you add them all together divided by the number of points, what would the average be? It's not as difficult here, thank goodness. All you're going to do is, if you're told, find the average rate of change between two x values, you're going to say, okay, what's the, so if this is our shape, what is the value at the first x value? What is it at the second one? And then you're pretty much going to imagine a straight line between them and figure out what the slope is of that line. That will be your average rate of change for this part, this curved part of the graph. Because it starts less than that slope, so it means pretty flat, starts to angle up, and then it gets really steep, so it would be more than. So the average is going to be that linear function. So average rate of change. Here's a quadratic. So the first one is between x is -1 and x is 0. So here's -1 and here's 0. So we want to know the average rate of change between the two of them. Now it's almost linear, but it's not quite. So we have to imagine, like, if I drew a straight line between the two of those, what would the slope of that be? So thinking slope formula or rise over run, doesn't matter which one you want to do. So it is over 1 up, it's terrible, up 5. So we would say, okay, over 1 up 5, so rise over run 5 over 1. That's it. And please don't call it slope, call it average rate of change. So slope is kind of like how we define it in our heads, but the actual answer is the average rate of change from x is -1 to x is 0. All right, x is 2 to x is 5. So from this point to this one. We'll do this one using the formula, so I can demonstrate both. So 2, 4. So we got 2, 4, and 5, -3. So remember doing slope, we say we've got our first coordinate x1, y1, x2, y2, and then it goes into our formula. So slope is y2 minus y1 over x2 minus x1. y2 is -3 minus y1, which is 4, all over x2, which is 5, minus 2. So then we get -7 over 3. So that is our average rate of change for, going from the vertex up here down to 5, -3. And we can see that it's over 3, it's down 7. All right, your turn. So here are your intervals. Pause the video, try and do it, and then come back and see how you did. All right, let's see how you did. -1, so x is -1, that's down here, to x is 2. So this one's got a bit of a curve going on, and then that was a pretty good straight line, I have to say. So we got -1, 0, and 2, 12. So that would be over 3 and up 12. So rise or run 12 over 3, simplify that, that is the slope of 4, which is our average rate of change. From 3 to 4, so 3 to 4, so we got 3, 12, and 4, 0. So x1, y1, x2, y2. So 0 minus 12 over 4 minus 3, which is minus 12 over 1. So you have an average rate of change of negative 12. How'd you do? All right, so next up is positive and negative intervals. And this one, again, very simple idea. You just have to know what it means by where are the positive and negative intervals. So this one is asking when are the y values in the function greater than 0? When are they positive? So between what x values are the y values positive or negative? So then, like, if we just divide our coordinate plane up this way, so green is when y values are positive, it's above the x-axis. Red is when they're negative, it's below the x-axis. At 0, they're neither positive or negative, so 0 is going to be an exceptional point. So we're just going to say, all right, well, I guess that means anywhere from minus 2 to the left has positive y values. Anything between minus 2 and 0 has negative y values because it's all below the axis. Anything between 0 and 1, also positive. Anything between 1 and 2, negative. Anything from 2 plus is positive. That's it. And we're going to write these as intervals again. So practicing that interval notation. So we would say anything from negative infinity to negative 2, both not included. Anything from, that would be positive. Anything from negative 2 to 0 will be negative. 0 to 1, positive. 1 to 2, negative. And 2 to infinity. Ooh, that's a terrible infinity. I promise that was an effort at infinity. 2 to infinity, also positive. And that'd be it. So you'd list the ones that are positive, the ones that are negative, and any notation will work unless you're asked for a specific one. All right, so I guess we're actually going to write these out here. So we had function positive, negative infinity to negative 2. We had 0 to 1. And we had 2 to positive infinity. The negative ones, minus 2 to 0, not included, and 1 to 2, not included. That's it. So you could write it as an equality, like you could have said minus infinity less than x less than negative 2. You could have done it in set notation, so you could say x such that 0 is less than x, which is less than 1. So that would be this one, like, or you can do interval notation, which is what we used originally. So you can see why I like interval notation. It's just the least amount of writing. I'm inherently lazy, I guess. All right, another one, your turn. I want you to try this one on your own. So what are the intervals for positive and then negative as well? And there are, let's see, so there's 2 of each. So make sure you are getting 2 positive and 2 negative intervals. Pause the video, come back, let's see how you did. Okay, welcome back. So we've got the key points are where it crosses the axis. And we know positive is above, negative is below. So we start with a negative value. Anything from negative infinity to negative 2 is negative. Both not included. Anything between negative 2 and 0 is positive. Anything between 0 and 2 is negative, it's below the line. And then anything from 2 onwards to positive infinity is positive. Now sometimes you will see like a set notation. This is like an uppercase U standing for union. So you could say, okay, we're including both of those together, so it's a grouping. It's not necessary unless, like, and if it is, it'll be a drop-down option. So if it's there, they'll give you the option of the drop-down. All right, that brings us to the end of today. Let's take a look at our key characteristics of graphs that you are expected to know and what we've covered so far. So this is the same slide as the last video lesson. So domain, range, and behavior is covered in video 1. Slope is increasing, or sorry, is the function increasing or decreasing? That was today. Average rate of change, also today. Minimum, maximum turning points, I mean, we've looked at a graph, we can identify them from there. If it's from a function, you're going to do that on a calculator. When we get there, I'll recap it with you. Otherwise, just Google how to find a max and minimum point using, and then insert your calculator model. So TI 83, 84, 85, whatever it is. If it's Desmos, when you put the function into Desmos, it automatically like gives you the turning points. Like you just have to hold your mouse over the graph and you can see them. Vertex is a turning point, so it's just a case of being able to identify those. We will work on that in like quadratics and also in transformations. We'll talk about the vertex. And then where are the zeros? This is going to come a little bit later as we start solving the different types of functions, but you did that in Algebra 1, so we're not really stretching far from Algebra 1 at the moment. All right, so your questions for today. How do I write an interval for increasing or decreasing? Well, you just say, when is the slope positive? What's the values of x, so the domain? That's the key part. You're always talking about the domain x. So between what x values is the slope positive? Between what x values is it negative? Average rate of change, you're calculating the linear slope between the two endpoints of the domain. And then when is the function positive or negative? When are the y values for the function positive and negative? So between what x values do you get positive and negative y values? And writing those in intervals. So after today, you should be able to do that Unit 1, Module 1, and the second folder, which is characteristics of functions. So you've got the video from today, which is at the start of that folder, and then you should be able to go all the way down through the practice problems and then ready for transformations after this. Talk to you soon.